Hello. Hi guys, good morning. Welcome back to a new video. In this UNC problem, number of wonderful strings. First of all, ki hal chal? I hope you guys are doing good and you are solving problem daily. Now, as soon as this problem and I was trying to solve it again, I realized this one meme. Leetcode ने अपनी औकात दिखा दी. So again, this is actually a very good problem, especially for the folks who it involves two very great concepts and mix them, and it is one kind of that problem. Let's see what it is. So it simply says, again, we'll go from very scratch, step by step. It says every word, we'll go word by word. Every word, it says that at most one letter appears an odd number of times. So we have a wonderful string. Now that string is called wonderful. I will say as a good string later on going forward. But that string is called wonderful string if at most one letter, which means what at most means? At most means at max. At max one letter, which means either it can be 0 times or 1 time. That is at max one, which means either 0 or 1. Appears an odd number of times, which means a letter can appear odd number of times, either 0 time or 1 time. Okay, so again, appearing odd number of times as in frequency of that character. So frequency of that character can be odd, either 0 time or 1 time. Remember everything which I'm telling you, because it is a very good problem. Cool. Now they have given the example. For example, you can see that C is occurring odd number of times because it is occurring 3 times. G is occurring 2 times. So at most one character is occurring odd number of times. In this, A is occurring even time, B is occurring even time. At most one character is occurring odd number of times, as in we can see that we are occurring 0 times, odd frequency. In this, A is occurring odd times, B is occurring odd times. 2 characters are occurring odd number of times, so it is wrong. It is wrong. Now let's come on to main thing. It says but to return the number of wonderful non-empty substrings in word. So word was a string. In that I can have roughly n square substrings. To be more precise, n into n plus 1 by 2 number of non-empty substrings. I have to return all the wonderful substrings, and we realized to identify if a string is wonderful or not, we will firstly have to grab the frequency of all the characters inside that substring. As you can see, A's frequency is 2, B's frequency is 2, and then after grabbing that frequency itself, we will see if the odd count frequency should occur at max 1 time, either 0 time or 1 time. That's it. So we realized if you want to solve this question, one way is that we will go and find all the substrings, and then out of all those substrings we will check what is the valid string, which means what is a wonderful string or what is a good string. So it will take O of n square number of substrings. For every substring, it will take O of n time to go and check the frequency. Out of all those frequencies, go and check what is the count of odd frequencies. If the count is less than or equal to 1, it is my good substring. Now we have already seen that this will take O of n cube, n square for substrings, and to verify it will take O of n. But we have also seen one very standard technique to optimize this O of n cube approaches, that while generating the substring itself, which means I less than n, j less than I, all that stuff, while generating the substring itself, make sure to take this count parallelly. So you don't have to do this counting stuff separately. So I can actually optimize it to O of n square, but still this will not work. Now interview will ask us, can you please optimize it? We will see, okay, can we optimize it? So we can either think of O of n or O of n log n. As soon as log n factor comes in, we know that we have a few standard techniques, either sorting, which means we sort the array, or maybe we can apply the techniques like merge sort or quick sort. Again, Aryan sorting and merge sort, quick sort, things are same. No. See, merge sort and quick sort are very special. They are actually divide and conquer approaches, right? Normal sorting is we just simply apply a sort function, but merge sort and quick sort are actually saying that we can apply divide and conquer approaches on an algorithm or a problem. Okay, we can maybe apply binary search, we can maybe apply Venn tree or segment trees. Usually this is not seen for normal interviews, but these can for sure occur. Now, as soon as the sorting kind of thing comes in, which means the order will change, but in this we have to deal with the substring. So one thing is, or like sorting doesn't look much, intuitive. Okay, let's think of that how we can solve it in O of n time. right? Okay. Now, as soon as we have to solve it in O of n time, we so far have realized that I have to go on to all the substrings and I have to also keep the count. What is the count of a specific character? Because if the count is odd, that will say, okay, that character has occurred odd number of times. So I need two things. First is the count of that character. If the count is odd, then I need the count of the odd frequency also. Why is the balloons? Cool. Now, so I realized, okay, this is the thing which I wanted. And in general, anytime, either I tell a DP problem, or I tell a 2-point problem, or tell a sliding window problem, or I tell a simple substring or a string problem, I always tell you, go on to any random pointer I. Go on to any random pointer I and then see what is happening. But always make sure, as you go on to a pointer, you should remember your aim. Maksad kabhi nahi bhulna. Your aim was that either the substring should have all the even frequency element, or your substring should have one odd frequency element and others are even frequency element. Always remember this. All this you can write in your paper also. Write in your paper also. Now, coming on, that we know that you have to maintain the frequency of each character, and as the frequency will become even, I will put that character in the even. Okay, this is the even character frequency, and if the frequency is odd, that is a odd character frequency. So I know roughly that I will have to maintain the frequency, and for sure I cannot go and try for all the n square frequencies. So basically I know one thing, I will maintain the frequencies, and I also have to make sure that I am maintaining the frequencies in just, okay, in the order I am going on, because I know that I can only go on the entire array once in one for loop. So, okay, I will make sure that I am maintaining, as I'm going from left to right, I'm maintaining this frequency of the character. Okay, how many times the character came in picture. For example, that, okay, I know that I have only these 10 alphabets. That's also a very strange fact which actually be used later on. So remember this, okay, that in the input you have given that you have only the characters from A to J. If that is the case, you will maintain, again, you have to maintain the frequencies, and you also know that you can only maintain from left to right, because you can only maintain once. So what you will do, okay, you will just maintain the count. Okay, let's say A was here, so A's count is 4. Let's say my B was here, so B's count become 1. Now let's say my C is here, so count of C is 2, and so on and so forth. Let's say D would have been there, so B's count is 3. So I've just given random counts. That is how I always approach a problem, even in contest or basically in this. I never took an exact array. Nah, I assume, okay, array can be anything, count can be anything, so just take it. So I took this frequency count. Okay, great. Now let's go on and see what is actually what I want. I want at a specific index, what is the contribution of that index? Because I know one thing for sure, how this simple substring problem works is that I go on to every index. What is the point of this index? The point of this index is I'll go on to this index and I will ask the problem for the ith index contribution. So how much contribution this ith index is giving me, okay, that contribution I will add in my answer, and I will take the contribution from every index. As I know I have to go on to every index, so I will take the contribution of every index. So I now know one thing, okay, if I am at the ith index, I have to go and ask for the contribution of that specific ith index. Now for the ith index contribution, and usually we say, okay, for the contribution of ith index, as we have not even gone on the right side, so for sure the answer, for me the answer is good subarray. For me the good subarray should end at the ith index, and maybe it can start it from anywhere. It can start from here, or maybe it can start from here, or anywhere. It can start from here or anywhere, but it should end at that specific ith index. Okay, now for me a good substring, this again ending at the ith index, I have to find, remember again, main aim is for you to get the number of wonderful non-empty substrings. So I told you that, okay, I will get a substring ending at the ith index. I have to get, okay, this, I have to firstly verify this is a good substring, and if yes, then what is the count of those good substrings ending at that index. So one thing is, okay, this substring, again, right now I have showed just one box, but they can be multiple such, okay, another one this, but ending all at that same index I. So first fact is that it should be a good substring. Again, if that good substring is, then okay, how many? So count will be important. As soon as count, again, I'm just showing you that what all you can think of at every step. As soon as count comes in picture, we know that we have to maintain the frequency, basically the count. Count is nothing but you keep tracking a hash map. What is the count of that specific thing? But Aryan, this is a sub-array. How will you maintain the count of a sub-array? Okay, no worries. But we know one thing, we have to maintain a count. We can maybe use a hash map or stuff. No worries. We can just think of later on that how we'll maintain the count of a sub-array itself. No worries, but we can think of later on. Now, for me, the good subarray, again, if you remembered, good subarray is one in which all the characters are either even frequency or one character is odd frequencies and other characters are even frequencies. Now, if you remembered, we have taken the exact same case so far that I imagine that I was maintaining the frequency as I was reaching at that ith index. I was maintaining the frequency. Okay, A, B, C, D, and up till J. The frequency of A was 4, 1, 2, and 3, and 5. Okay, I was simply maintaining the frequency itself. As soon as I reached on at this ith index, I have to go and verify if this is a good subarray or not. If this is good, which means all the elements in this, again, in this purple of violet jo bhi hai, this, all the frequency should be even. As you can see, here it is even, odd, odd. But I have to make sure in this portion, this purple portion, all the character frequency, which means A to J, it should be even, which means either it can be 6, 2, 4, 8, 2, 6, like 2, 2, 2, 4, 8. So it is even. It can be anything. It can be 6, 2, 8, 10, 40, anything. But every character should have even frequencies. Even having no frequency, as in the frequency of 0 is also even frequency, right? So I realized, okay, I can have multiple such variations of even frequencies. So rather, let's give a parity. Okay, so I told that, okay, I know that I am only concerned about odd or even frequencies. So I have just two options, either 0 or 1. So I will just simply assign a 0 value to a even frequencies. So A to J will have a 0 frequency. Okay. Same way I realize, okay, that from A to J, again considering only this purple portion, I need to make sure that every character should have even frequencies. Just one character can have odd frequencies. So how will it look like? It will simply say, okay, A, B, C, D up till J. A is having odd frequencies, rest all are having even frequencies. Maybe B is having odd frequencies, rest all are having even frequencies. Maybe C is having odd frequencies, rest all are having an even frequency. And again, the same will go for E. E is having odd frequencies and rest all are having an even frequency. So these will have how many options? These will have 10 possibilities. So you realized that for this purple string, to be good, I have one possibility that, okay, for this all are even, which means one possibility is this, and remaining 10 possibilities can be that, okay, all other are even, just one is odd, which means these 10 possibilities. So in total I will have 11 possibilities for this purple one. But so Aryan, are you saying that I know that this is what I'm looking for in my answer? Or basically I'm looking for this purple thing, and this purple thing is this specific thing, or this thing, or this thing, or this thing I'm looking for. And Aryan, you are saying that I am only concerned about the parity of the frequency, so maybe I can also convert this input from the very beginning to the ith index. I can also convert this to maybe the parity, as in 0 or 1. So I converted that to a 0 or 1. Simple. Even 0, odd 1, even 0, odd 1, odd 1. Right? Now, but if you remembered, you are curious, or basically you are concerned about this purple thing. But you realize that you are only maintaining from the very beginning. This thing which you are maintaining, because this thing you will maintain for every index I, right? You are maintaining for every index I, but you are maintaining it from the beginning itself. From an arbitrary index ending at some specific thing, you are not maintaining this. You are maintaining things from the very beginning, everything. So I realized, okay, I want to find this white thing again. I want to find this white thing. I know this pink thing, and as I would have done this pink thing for this index when the I was here, so I also know this red thing. So I realized I know the red thing because it is the same way saying this is a pink thing. Again, I am using colors because I don't want to use numbers or alphabets. I want to keep it generic, and this is how you should also approach. Don't give numbers or values. People give it, and that's very confusing because you never know if I'm actually telling you for that specific case or in general. It is general. So I realized, okay, this ping thing, and get index I, same ping thing. Again, this ping thing is this specific value. Right? The same ping thing I can achieve for red thing also when I would have iterated from here to here. Okay, so I realized I know this red thing, I know this ping thing. If I just do a subtraction of this red thing from my ping thing, I will get this white thing. Oh, that seems like a concept. So Aryan was saying that you are maintaining the count, or basically the prefix sum of frequencies of all the characters. Yes, I'm maintaining that. And at every index, I should also store this entire pattern or snapshot of the frequencies. Exactly. So far, up till here, up to this point, you must have realized that what all I needed. At a specific index, I need the entire snapshot of all the characters A to J and their corresponding frequencies. So that, because why I need it? Because I would be needing to go at some index J and ask for the exact same snapshot. So I have to store this snapshot somewhere in a hash map or somewhere, but I have to store the snapshot. So I realized that, okay, again, storing the snapshot, you can store it as an array of size 10, or as you can see, it's a simple 0 or 1. So maybe you can make a mask of it. How? If you had already seen how a mask is made, again, we have not reached the final answer, but we are just simply going through it. So we realize, okay, if let's say, if I say, okay, A, B, C, D, let's say all this is there, and I know that A's frequency is 1, as in the parity of the frequency is 1, B's parity is 0, as in B frequency is even, and then odd. So it is 1, 2, 4, 8. So this value is a 9. So it is either you can store a vector of an array, sorry, an array you can store in which you can give these values 1, 0, 0, 1, and you can store this in a hash map, or you can basically use, because you know it is either a 0 or a 1, because you're not concerned about the actual frequencies, you're concerned about their parity. So you can maybe take and convert this to a number and use this number. This is called as using bit manipulation techniques. Now coming on back, we have diverted from our main aim. Maqsad kabhi nahi bhulna. Your main aim was that, okay, for all this, again, let's not change it. For this white thing, you have to find out this pink thing, you know, which is simply the prefix pattern which you have been following. This is the prefix pattern which you have been following. Again, Aryan, how to generate this prefix pattern, we'll see all that stuff. But you know that this says it's an even count, this says it's an odd count. Frequency is even, frequency is odd. And how to generate this? As soon as, let's say, I go on to the next index, if I encounter a B again, so for sure, if I encounter a B again, whatsoever B's frequencies would have been there, whatsoever parity would have been there, if I add a new B. So if the B's, as you can see, if it was odd, I added a new B, it will become an even. Or what if it would have already been an even? If I add a new B, it will become an odd. So basically, as soon as a new character is added, basically existing parity is being changed. If it will be even, it will become now odd. If it was odd, it will become now even. As soon as new character is added, my prefix sum pattern, how I will generate it, simply change its parity. Because even will become odd, odd will become even. As soon as the characters are adding incrementally. Okay, we have known that how we'll generate this prefix pattern. Now coming on that, again, this is blue thing. We would also know at this index whatsoever is there, but Aryan, at this index you are saying, which means that are you trying to go on to all the previous indexes J? No. If I will go on, I will still come on to O of n square, because then I will have to go on for I for all the previous indexes J. I don't want that. I absolutely don't want that. So what I want, okay, this white thing, I realize this is either this all are even, which is one pattern, and then the remaining 10 patterns. So in total, I have 11 patterns for this white, but I also realized that I cannot get this. I cannot get this white pattern because I never know what's the starting point. But somehow I know this blue pattern, and I have been storing this blue pattern also. But technically, I know my aim. My aim was this white pattern. My aim was this white pattern. But I'm saying that technically my problem knows this blue pattern. I know white pattern, my problem knows blue pattern, and I want my problem to get the count of this white pattern. How to use? Simply use your blue pattern to relate it with the white pattern. How? As we saw previously, that this pink pattern, which is the prefix, is the total value, right? You know the white value. You know the white value. White values can be a 0, 0, 0, 0, saying that all are even frequencies. So white pattern is 0, 0, 0, 0. So if I just ask, this is the total, this is the white pattern, what will be the blue pattern? What will be the blue? I'm asking you, because you told that currently you know at the ith index what is the total value, which is the pink pattern. You know that what your white pattern should be for your substring to be good. Then ideally, by your case, what should be the good blue pattern? Good blue pattern should be a 0, again 0, 1, 0, 1, 1. But Aryan, how you got this? I simply got this by saying, okay, I know this 1 is saying I have a odd frequencies. The 0 saying I have a even frequencies. So odd minus even. It is a simple prefix subtraction, because I know if this is a total, which is pink pattern, if I remove this white pattern, I will get the blue pattern. I'm doing a simple subtraction. So if I come on back, I realized, okay, odd minus even is actually odd. 5 minus 2 is a 3, odd number. 5 minus 2 is a 3, which is odd number. Even minus even, 4 minus 2 is actually a 2, even number. So 0 minus 0 is a 0. 1 minus 0 is a 1. 1 minus 0 is a 1. And same way, Aryan, what if 0 minus 1? Again, firstly, it will all be zeros, because of the white pattern which we have taken. It is the all are zeros, that's for sure, all are zeros. But technically, if there would have been a case, if you have to think of, then 0 minus 1 is also a odd, because if I take 6 minus 3, even minus odd, it's a odd number. But technically, you know that this all white pattern will be a 0 because of the case 1 which you have taken, case 1 where all are even. So you realize, okay, this is the blue pattern which you wanted, right? Okay, this is the blue pattern which you wanted. And you also know that you have been storing this blue pattern in some of a hash map. But Aryan, what I store for this? I will store the count or the frequency of it. But okay, we'll go on to later on. But firstly, how, okay, right now, Aryan, you did a simple subtraction of it. Makes sense. So are you saying that like earlier in the very beginning, you told me that I can convert this entire 1010 to actually a bit mask, and then I can convert that to a number. But then Aryan, if this entire number is 9, and if I have some other number, let's say 1000, which is 8, so Aryan, how will I get the new number which is 0001? And like, actually I'm concerned about this 000 individual values. Yeah. So for that, we simply know one very basic fact, that what is the XOR property? XOR property simply says to me very simple basic thing, that 1 XOR 0 is a 1, 0 XOR 0 is a 0, 1 XOR 0 is a 1, 0 XOR 1 is a 1. So whatsoever this subtraction property is following, the same properties followed by my XOR. So what I can do is I can take the value, total value of my pink pattern, of my white pattern, and I can do a XOR operation on them to get my blue pattern, And the same way, again, this is I did for when all are even, when my white pattern is all are even. Same way I can repeat that same process for the other 10 patterns in which 1 is odd, and I know either A can be odd or B or C or D and so on and so forth. So same I will repeat that this is my total, which is a pink pattern. This white pattern, again, here you can see my A is 1. In the next step, my B can be 1, my C can be 1, my D can be 1, and so on and so forth. And the all other are zeros. Then I have to make sure that only this specific bit should be impacted. Only this bit should be impacted. If that is the case, I will say, okay, this is 1, and rest all remain as it is. Rest all bits remain as it is. And what is this happening? 0 minus 1, as in, okay, we have this specific frequency, which is the even frequency, and we have the odd frequencies. Even minus odd is actually also odd, so it is 1. Then all other remain same. So this I got the blue count. But Aryan, getting count and stuff, it is good, and we also got that count. But how will this blue count be useful? This blue, again, you have got the blue value, which is the blue prefix value. We earlier had only the pink value, which is the pink prefix value or the pink pattern, prefix pattern, but now we have also got this blue pattern. This blue pattern, as you can see, blue pattern and blue pattern, and total blue pattern, I will have 11 blue patterns because of 11 white patterns. One pink pattern, 11 white patterns will give me 11 blue patterns. So I realize I will get the blue pattern, which is the blue prefix for me. But if you remember, I wanted the number of wonderful substrings, and I am now saying wonderful substrings ending at index I. So I want at any index I good substrings having white pattern, and I know for that I correspondingly got blue pattern. So I will maintain the count of strings, or basically the count of prefixes starting, because prefixes is starting, and that count I will maintain for the blue pattern. And I know that blue is directly related to white. So for this specific white pattern, if I got this blue pattern and this blue pattern, which is 0 1 0 1 1, if this blue pattern count, if I get the, let's say if this blue pattern count is 4, this blue pattern count is 4, it simply says that for the specific one pink pattern, and currently, okay, I have taken all evens. Now I am saying that all evens, and I am saying this is 4. This, whatever is there, blue pattern, it can be four such variations, 4 such possibilities can be there. So I can also say, technically, 4 such possibilities can be for the white pattern. So I realized that I will take the reference, okay, blue pattern, that there can be one such possibility that, okay, 0 0, that 0 0 is occurring here, let's say. Then a remaining can be this entire portion, or maybe again I am saying this blue pattern, and this blue pattern I am saying it can occur 4 times. Technically, let's say 0, or maybe some value I want. Again, I'm not going the exact value, but let's say I wanted some 0 1 0, and that is occurring, okay, 1 time here. And let's say 0, again I'm seeing specific values occurring, that specific blue pattern is occurring 4 times. So I can have 4 such prefixes, 1 2 3 4. If I have 4 such prefixes of blue pattern, technically I can also reverse the same thing and can say that I will have 4 such these pink patterns. You saw how I made it, and that is what I wanted. Cool. So I'm simply saying that I will simply keep a track of the count of this blue pattern, and how I will do it, I will simply take a hash map for it, which will keep track of the count of this prefix pattern which I am taking so far. And you can see that this pink pattern is also nothing but a prefix. Sorry, this pink pattern which was ending at the ith index, it was also nothing but a prefix pattern. So you will simply say that map of this prefix pattern, because when you are done on ith index, do a plus plus, that one, this pattern you have got. Cool. And make sure this pattern is the parity, not the frequency, right? So this can repeat, this pattern can repeat, which means AA, the parity of A is even, AA, the parity of A is again even. So A will be 0 here also and here also, but A will be 1 here and here. So you see, this prefix pattern can repeat. Don't confuse it with the frequency. This is a parity pattern. Cool. Now let's come on to the actual code. You have got the entire intuition for every step. Why we take frequencies, why we take prefix pattern, how we used our blue pattern to actually infer what is the count of the white pattern, and we want actually the count of the white pattern. White pattern was this pattern itself. This pattern itself, ending at the ith character and starting from anywhere. Cool. Let's see the code. Code is exactly same as what we saw. We will just simply use for the entire. Again, you can take the array also. You can take the array also from A to J for this even all the even occurrences or all one of the odd occurrences. For these 11 white patterns, you can take an array also. If you are confused with bit manipulation, but I will highly recommend that please consume this bit manipulation as a very good stuff. It is very helpful. So we realize first thing that this is a map which will store the frequencies of every prefix pattern. Make sure what this is. It will store the frequencies of all the prefix pattern. For me, the prefix pattern is nothing but A to J. A to J are the characters. And in the very beginning, in the very beginning, no character is there. So count of all the characters is 0, which means that parity of all the characters is even, which means that map of 0 is actually a 1. You got why it is the case? Because in the very beginning, I have no character, which means the frequency of all the characters is 0, which means the parity of all the characters is even, which means that for all the even parity elements, I have already 1. Okay. Because I have nothing. That's a 1 value. Now let's come on and we will actually keep the prefix pattern. This prefix pattern indicates prefix. For that specific prefix, what is the frequency? If the frequency is odd, then it's a 1. Frequency 0, then it's a 0. This is the final answer, which is a number of good, wonderful substrings. Then I go on to every character. Firstly, I will see, because if you remember, I have to firstly go and grab this specific, where it is gone? Yeah, this specific prefix pattern, which is ending at the index I. I wanted this pattern, right? So I will firstly get this prefix pattern. How I will get this? Okay, existing prefix pattern, then a XOR value of 1 left shift the current character. So if I am saying the existing prefix pattern was a 0, 0, 1, 0, which means A is occurring even number of times, B odd, C even, D odd. Then I will say, okay, the current character is B. So B is nothing but I will say, okay, 1 left shift. Again, B in technical terms occur at the first index. As you can see, first index. So A, B, C, D. B is occurring at first index. How to know which index? Simply B minus A is a 1. This will give me, okay, if I do a C minus A, it will give me a 2. So it says that C will occur at index 2. So I know that at index 1, because it was a B minus A, which is 1, I need to change the parity. So I know that my number, again, let's take it as a, let's say C. So it will be a 2. So I know that at index 2, a new character C is coming up. So this character C, again, this is actually a variable, but let's say this C variable is holding a C character. So this character C is coming up at index 2. At index 2, I have to change the parity. To change that, first we make a mask. How will we make a mask? I will simply say that, okay, take a 1 and left shift and keep on left shifting that 1 twice. So 1 is here, left shift 1 time, left shift 2 time. So now my 1 is here. Remaining all will be 0. This is called as a mask. This mask will help me to change the parity or at that character at that index 2. How? As I will do a XOR operation, the parity will change. This will become a 1 and rest all will remain as it is. Rest all will remain as it is. So this is what I am doing. As a character C is occurring, right? I am changing its parity in the prefix pattern. And then I remembered if I go back, if I change, if my white pattern was a all even, then my blue pattern which I will get is exactly same as that of the pink pattern. You can see 0, 1, 1, 0, 1 and 1. So technically I want to get the count of this blue pattern, but this will be same way saying get the count of this total pattern so far. So I will go and back get the same stuff, get the count of this total pattern, which is a prefix pattern right now. But right now make sure when I am taking this count in my answer, I am actually referring to even pattern count when my entire white pattern is even. This is what I am referring. But also remember, this is one such pattern. Remaining 10 patterns are also left, in which I will go on and try for all the characters from A to J. For all the characters, I want to get that blue pattern. How will I get? Existing pattern, which is a total prefix, XORing it with, again, exact same funda as we did. Because right now I will say that this character CH will be 1, then maybe the next character which is B will be 1, then C will be 1, then D will be 1, and so on and so forth. So I will set that specific character CH to be 1, and the remaining other ones will actually be a 0. Then if I do a XOR operation between them, I will get my new blue pattern, which is this called as old pattern, odd pattern. This odd pattern is saying, bro, when you have given one odd frequencies and remaining other as even frequencies, this is your blue pattern, which is odd pattern. And then simply get the count also in this answer. Ultimately, when this entire thing is done, which means you have covered all the 11 patterns, make sure to increase the count of this prefix, which is, please make sure to increase the count of this specific prefix pattern also, because you will go on to the next index I, and you actually wanted to use this prefix pattern for the later future on purposes. So just make sure to increase this and return an answer ultimately. You will see that you are going on to all the characters of the word, which is O of n. For every character, I am iterating on the entire A to J range, which is again 10 operations. So it will be O of n to 10. And space will be O of n because of this map. But Aryan, this map is only storing the patterns. You will see, because of this character C, I can have at max n distinct patterns. Again, technically you might say, Aryan, this is nothing but you are having a 10 locations in bit mask. Basically, in a mask, you have 10 locations. So technically, it can be a 0 or 1, 0 or 1, 0 or 1. So it can be 2 raised to power 10. Okay, makes sense. So you technically are actually keeping this pattern, and that can be a XOR. So you can also say it as 2 raised to power 10. But okay, that will not matter because it will be O of n itself. You can say again, it will be O of n technically, because in this O of n operation, what you are doing is that you are going on to all the prefixes, and the prefix can be a 0 in the very beginning. You are just doing a XOR. So in worst case, I can have these many distinct values, but it is okay. 2 raised to power 10 can be a value, or you can take that n, whosoever is minimum, that's your answer. That's your answer, and that's the space for you which you will be using. I hope you guys got it. Again, people will bring in a 15 minutes video for it. Great. But again, the worst part which I have seen, I might end up giving a gibberish things which people say, okay, don't repeat stuff. So I tried to not repeat stuff in this video. Please let me know that what are your comments. I will take it again. People just usually say, okay, that whatever you recommend, please do comment down below. That it helps me improve also, because I actually want to deliver the best to you. But yeah, in this, just let me know that at what points I repeated stuff again, which I should not have repeated. But yeah, that's it. If you guys have not checked out the Discord or checked out this new channel in which we are putting in the actual videos which will help you apart from your programming, then please go and check the description below. And let's see you guys in the next video. Then bye, take care, bye bye.